So we're going to go through some questions on isomerism now. The first few pages will be on structural isomerism, and then we'll do some questions on stereo isomerism. If you'd like to, you can download the worksheet and answers by following the link on this slide. So these first few pages are just some questions on structural isomerism. So first of all, we're going to name and draw all the molecules with the formula C6H14. And then name and draw a carbon chain isomer of 1-chlorobutane. These questions we're going to attempt to have a structural isomer of butanol, but we've got to retain the C double bond O group. And we're also going to name and draw all the structural isomers of formula C5H10, and they're going to be chain isomers, so we're not going to attempt to draw all the ring isomers. And here are some questions on geometric isomerism. We're going to fill out a table where you've got the name and we're going to draw the structure and decide whether that will have EZ isomerism, and if it does we will draw the other isomer. And there's a second page to the table there. So let's have a go at doing the answers for the structural isomerism questions. So the first challenge is to draw and name all the molecules with the formula of C6H14. So the first, most straightforward one is going to be, of course, hexane. These are going to be alkanes that you have. So let's reveal the answers. So first one, we've got hexane. Then you can shorten the carbon chain to give you one based on pentane and put the methyl groups in different places, which we've done here. So you've got 2-methyl pentane and 3-methyl pentane. Of course, your longest chain here is 5 carbons, hence a pentane. Then you go one shorter to butane here, and you can have methyl groups on the second and third. And then finally, you can have a 2,2-dimethyl butane with your methyl groups there. So we're now going to look at draw and name a carbon chain isomer of 1-chlorobutane. So you only have to give one answer for this, but obviously I'll show you all the possible options you have for this. So you've got, obviously you've got 1-chlorobutane, so I'm just showing you what that looks like there. So that wouldn't be an answer. So let's put that one in brackets. So you can have either 2-chlorobutane, or you can shorten the carbon chain. So you've now got a propane chain with a chloro on the first and a methyl on the second, and then you can have propane again, but with both the chloro and the methyl group on the second carbon. So we're now going to look at a structural isomer of butanol, but we've got to retain the C double bond O group. If you don't do that, then you can have quite a few possibilities, including lots of ring structures, which could take you a while to work those out, particularly as we're at the beginning of the organic chemistry course. So we've got butanone is probably the most obvious one for you to go to. Rather than an aldehyde, you're going to have a ketone instead. The other alternative is, of course, to keep it being an aldehyde. This time we're going to have propanol with a methyl group on the second carbon. You don't need a number, so you don't need to call it 2-methyl propanol, because the methyl group has to be on the second carbon. If it was on this carbon, of course, it would become butanol. And then finally, for structural isomers, we're going to do all the structural isomers with the formula C5H10. Now, I haven't actually shown all of these because, of course, you can have lots of ring structures, which I won't go into, but you may be interested. So, for example, you could, if you wanted to, have had a 5-carbon ring like so, which would have the formula C5H10. Or alternatively, you could even have a ring of 4 carbons with a methyl group coming off. All of these would be okay, but we'll just do the ones which retain the double bond to make it a little bit easier. So first of all, you've got pentguanine here. So you've got your carbon double bond on the first carbon, but you retain your 5-carbon chain. And again, if we go to pentuine, again, you've got your 5-carbon chain there, but you've got your double bond on your second carbon. Then we'll have a look at, let's go for this one. So now you've got butanine again, but you've got a methyl group, coming off your third carbon, which is that one. Then you've got a butyne here again, but your methyl group coming off your second carbon. And then finally, well done if you got this one. You've got 2-methyl butyne. So this is your butyne, and then you've got your methyl group on the second carbon there. Right, so let's have a look at the answers for geometric isomerism or stereoisomerism, but we are only looking at isomers caused by a carbon-carbon double bond. So we have a nice table to fill in here. So the idea is to first of all draw the structure and then decide whether it has EZ isomers. So let's have a look. Methyl propene. So this is methyl propene here. So let's just make sure. So we've got our 3-carbon chain there, and your carbon-carbon double bond there, and your methyl group on the second carbon. Again, it has to be on that second carbon. You don't need a number. If it wasn't, it would become butene. Can it have EZ isomerism? No, it can't. And the reason why is because on that carbon you have 2 hydrogens, so you haven't got different groups on that carbon, so it can't have EZ isomerism. So 1-chloropropene now. So a similar molecule, but we've now got a chlorine attached. So again, we've got propene here with your 3-carbon chain and your chlorine on your first carbon. And this can have EZ isomerism because you have an H and a Cl on that carbon, and on this carbon you have an H and a methyl group, so you've got different groups on both carbons, and therefore you can swap these 2 groups around to give you that isomer. Next one, 2-methyl pentuene. So it sounds like it should have EZ isomerism with a name like that, but when you draw it out, so this is your pentuene going along here. So 1, 2, 3, 4, 5, and your double bond on your second carbon. But also on that second carbon you have a methyl group, which means when you come to look at the structure, you have got a methyl group, 2 methyl groups on that carbon there, and therefore because they're the same, it doesn't matter if you swap them around, so you cannot have EZ isomerism for that one. And the final one, 2-ethyl pentuene. Just to go through the name of this one, here is your pentuene going along here. So that carbon chain there, and your double bond starts on your first carbon there, and on your second carbon here you've got your ethyl group. So can that have EZ isomerism? No, it can't, and the reason why is because on that carbon you've got H's, so it doesn't matter about swapping those around. Right, so final set of questions. Let's go. So 3-methyl pentuene. There's the molecule there. So again, let's just go for the name. So we've got pentuene. Here's my chain here. 1, 2, 3, 4, 5 with your double bond on your second carbon there. So it's your pentuene. And then you've got your methyl group on your third carbon there. Can that have EZ isomerism? Yes, it can. Because on your carbon here you've got a methyl group and an H, which of course different, and on this one you have a methyl group and an ethyl group, so they both can have they both got different groups on the carbon atom, and therefore you can change those around. So in this picture I've swapped over these 2 here to give you that molecule there. So we'll go for the next one. So this one's got a bit of a more complicated name. So 3,4-dimethyl hexathreene. So let's find out how we got to this structure. So if we start here, that's 1, 2, 3, 4, 5, 6. So that's your carbon chain there. And on carbon number 3 is your double bond. And also on carbon number 3 is a methyl group. And on carbon number 4 is a methyl group. That's how we got the name. So can we have EZ isomerism for that molecule? Well, yes, we can. And the reason why is because on this carbon, you've got a methyl and an ethyl group. And on this carbon, you've got a methyl group and an ethyl group. So if I swap, let's swap these 2 around now to get that structure there, which is, of course, different because in your first molecule, your methyl groups are on the same side of each other, and in this molecule your methyl groups are opposite sides. And our final one then is 2-bromo-3-chloro-butene. So let's have a look at the name. So here is my 4 carbon chain, 1, 2, 3, 4 there, and your double bond on your second carbon. So that's your butene. And then on your second carbon is a bromo, and your third carbon is a chloro. So that's how we got the name. And this can show EZ isomerism, and the reason why is because on this carbon I've got a methyl and a bromo, and on this carbon I've got a methyl and a chloro. So we can swap those around, and in this new one I've swapped those two around to give this molecule here. And again, if we have a look, in the first molecule, you can see that your methyl groups are on the same side of each other, and in this second molecule, your methyl groups are on opposite sides of each other. So well done on those. I hope you managed to get those right. You'll be doing lots of different examples of isomerism throughout the course, and obviously we'll be doing far more EZ isomerism when we come to study the alkenes.